Now, these little squigglies aren't here just to be cute. They actually mean the partial derivative of this function in terms of x.
But what does that even mean?
In two-dimensional calculus, we can find the change in y as we move in x. That's pretty simple, but in 3 dimensions, it's gonna be a little bit different because we're not just moving it to the left and right, we're moving in different directions. And that's why the partial derivative just focuses on the change of this function as we move in the x direction. Whereas this function is telling you to take the partial derivative in terms of y. So we're looking at this function of the change of this function in terms of y, or in the y direction. And solving it is pretty simple. Whenever you're trying to take the partial derivative, in this case in terms of x, you're going to treat every other variable like a constant. So in this case, we're not going to really worry about y, we're going to treat it like a constant. So I have two things being multiplied. This function here, you can call this your u. This function here, you can call this your v. Whoop, I put a v on there. There we go. So we're going to solve this by taking the product rule. So we're going to do u prime v plus u v prime. We're just going to follow the same rules that we learned in Calc 1 and Calc 2. So when we start taking the derivative of u, it's going to be the derivative of this. Now remember, y is a constant. So this is just going to be y times sine of x plus y squared plus our u value. So it's going to be x y times the derivative of this value here. So we're going to have cosine of x plus y squared times the derivative of what's inside, which is going to be the value of this. Now the derivative of x is just going to be 1 plus, and then the derivative of y squared, remember that's a constant, so that's just 0. So really this is just 1. And really that's all there is to it. There's going to be a lot of different questions that they could ask you, but this is how you take the partial derivative of this function in terms of x.